Well, the TI-99 still isn't booting, and after a lot of head scratching, we found some interesting clues and a few problems we didn't expect. Welcome back to Earie's 8-Bit Workshop. I'm sorry it's taken quite a while since the last episode to bring you the next update in the TI-99 build. Since the last episode, I've been trying to figure out why this thing still won't boot, and along the way we've uncovered a few issues worth sharing. The first step was a close inspection of the board, and straight away I spotted a capacitor that had popped and several others that had visible cracks. So I'm assuming we've had a bad batch of capacitors there, and before filming this episode I've replaced them all. I also verified all of the resistor values across the board. A few in the top left-hand corner turned out to be wrong. Not the design's fault, but mislabeled parts in my parts drawers. So lessons learned, always test resistors and capacitors before installing them. After that, I ran all of the logic chips through the Retro Chip Tester Pro, and every one of them passed. And it was at that point I reached out to the forum on AtariAge, where they're discussing building the TI-99 for advice, and JasonACT kindly offered to lend me his PicoPEB. With a custom firmware, the PicoPEB can log commands that are being executed by the CPU. A really clever way of working out what's going on. The folks on the forum also pointed out a few design errors worth fixing. Firstly, the reset button. If used too often, it can cause a fault on the board and should be removed. So it's gone. Second, the second power LED on the board draws too much power for the design. So that can cause damage when it's used. So that's gone. And finally, the 10.7 MHz crystal is slightly off. It should be actually 10.738635 MHz in order to produce a stable NTSC signal. So we've corrected all of those issues on our board now. From the boot log, JasonACT suggested two likely culprits, either a bad CPU or faulty glue logic, despite the chips passing the RCT Pro. So I tried swapping to a different CPU. And while I changed the pattern of the boot log, it still didn't get us working. And that led me to something that I'd completely overlooked. In 2021, CPUville.com, it documented a widespread issue with Counterfeit 74LS series ICs from China. Chips sanded down and restamped with a fake Texas Instruments logo. I'll put the link in below. The giveaway is that the TI logo is incomplete, and unfortunately over half of the logic ICs on my board have that same bad logo. So it's very likely that some of the system's instabilities are coming down to counterfeit logic chips. So I've been advised to switch to 74HCT logic ICs. They're less common and less likely to be counterfeited, still fully compatible with the 74LS design. So I've ordered, hopefully, genuine 74HCT chips, and I'm now waiting for them to be delivered. While waiting for the parts, I decided to build my own PicoPEB. PicoPEB was originally designed by JasonACT using mostly through-hole components. More recently, dabone remixed the design into SMD version, which made it possible to order a mostly pre-assembled board directly from the PCB manufacturers like JLCPCB. In the first video in this series, we described what a PEB was. It's a peripheral expansion box which could hold disk drives, serial ports, modems, speech synthesizers, and so on. The first iteration of a Raspberry Pi PEB, known as a TP, was a device that allowed a Raspberry Pi board to take over many of those same functions. It could also provide internet access from the TI-99 4A, including limited web browsing, telnet, and FTP. It could also provide virtual disk images, and even allow a USB mouse to be attached. The second iteration, a TP32, embedded the Raspberry Pi onto the board and added a 32K expansion to the TI-99 4A. We're now on to the third iteration. It swapped out the Raspberry Pi for a Raspberry Pi Pico, and this has brought the cost down from over $100 to less than $20. And here it is. Unfortunately, when I placed my order, the PSRAM chip was out of stock, so I had to solder it on myself here and here. Now, I've never soldered SMT devices before, so after watching a couple of tutorial videos I decided to give it a go. With plenty of flux and a bit of practice, I tackled one corner of the IC and the opposite corner of the IC, and I was off to a good start. Of course, I made the classic beginner mistake, too much solder on the iron. My first drag solder left the whole side bridged, so I spent a few minutes carefully cleaning it up with solder braid. The second side went perfectly. And by the second chip, both sides worked first time. After that, I soldered on the Pico module, the reset button and the edge connector, and just like that, I had my own working PicoPEB. Now this is going to be invaluable, not only for continuing to diagnose the TI-9922, but later as a full PEB device once the system is running. So that's where we're up to. We're waiting on genuine 74HCT replacements for all the suspect logic chips. Once they arrive, we'll swap them out and run another full diagnosis with the PicoPEB. If you've had experience with counterfeit logic chips or found a reliable supplier for your 74 series chips, please let me know in the comments. I'd love to compare notes. In the next episode, we'll replace all the 74LS Logic series chips and hopefully, finally, get the system to boot. Thanks very much for sticking with the project, and if you're following the TI-9922 build, please make sure you subscribe so you don't miss the next update. Until next time, see ya.